What is an expert system? An expert system is a computer program designed to mimic the decision-making abilities of a human expert in a specific domain. It uses a set of rules and knowledge to analyze data and provide conclusions or recommendations, effectively simulating the expertise of a human specialist. Components of an expert system. 1. The knowledge base. This is the core component containing domain-specific knowledge, facts, and rules. It is created from the expertise of human specialists and can include heuristics, procedures, and data about the domain. 2. The inference engine. This component applies logical rules to the knowledge base to derive new information or make decisions. It uses reasoning techniques to process the input and provide output based on the knowledge base. 3. The user interface. This allows users to interact with the expert system, input data, and receive advice or recommendations. It can be graphical or text-based. 4. The explanation system. This feature provides explanations of the reasoning process and the conclusions drawn by the expert system, helping users understand the logic behind the decisions. Example: domain medical diagnosis. How an expert system works in medical diagnosis. The knowledge base contains medical knowledge such as symptoms, diseases, diagnostic tests, and treatment protocols. It includes rules like, if the patient has a fever, cough, and shortness of breath, consider a respiratory infection. The inference engine uses forward chaining, which is a data-driven approach, or backward chaining, which is a goal-driven approach, to apply rules from the knowledge base. Forward chaining starts with the patient's symptoms and applies rules to infer possible diseases. Backward chaining starts with a potential diagnosis and works backward to see if the patient's symptoms support that diagnosis. The user interface allows doctors or medical staff to input patient symptoms and medical history. It displays diagnostic suggestions, possible diseases, and recommended tests or treatments. The explanation system explains how the expert system reached a particular diagnosis. It provides a step-by-step rationale, such as, the patient has a fever and cough, which are common symptoms of a respiratory infection. Based on the severity and other symptoms, pneumonia is a likely diagnosis. Workflow of an expert system in medical diagnosis. Input collection. The user, such as a doctor, inputs the patient's symptoms, medical history, and any other relevant data into the system. Rule application. The inference engine starts applying rules from the knowledge base. For example, it checks if the input symptoms match the rules for various diseases. Diagnosis generation. The system generates a list of possible diagnoses based on the rules that match the input data. It may rank the diagnoses based on probability or relevance. Recommendation. The system provides recommendations for further diagnostic tests or immediate treatments based on the most likely diagnoses. Explanation. The system offers an explanation for its suggestions, detailing how it reached the conclusions and which rules were applied. Example scenario: patient case, symptoms, fever, cough, shortness of breath, medical history, recent travel to an area with high incidence of respiratory infections. Expert system interaction, input collection. The doctor enters the symptoms, fever, cough, shortness of breath, and travel history into the system. Rule application. The inference engine finds that these symptoms match several diseases but pays special attention to rules about respiratory infections. Diagnosis generation. The system suggests possible diagnoses such as influenza, pneumonia, and COVID-19, with pneumonia being the most likely based on symptom severity and travel history. Recommendation. The system recommends a chest X-ray and a COVID-19 test to confirm the diagnosis. It also suggests starting empirical antibiotic therapy for pneumonia while awaiting test results. Explanation. The system explains. Based on the patient's symptoms and travel history, pneumonia is the most likely diagnosis. A chest X-ray will help confirm this. Considering the COVID-19 pandemic, a test is also recommended to rule out COVID-19. Advantages and challenges. Advantages: 1. Provides consistent and expert-level advice. 2. Increases efficiency in diagnosis and decision-making. 3. Can handle complex and vast amounts of information. Challenges: 1. Requires extensive and accurate knowledge base. 2. May struggle with ambiguous or novel cases. 3. Needs regular updates to reflect new medical knowledge and guidelines. An expert system in medical diagnosis uses a structured knowledge base and inference engine to simulate the decision-making process of a human expert. By inputting patient data and applying medical rules, the system can provide reliable diagnostic suggestions and recommendations, assisting healthcare professionals in delivering accurate and timely care. If you need any more explanations of AI terminology, hop over to Ai-Epicentre.com.